Swayam Prabha. Digital India. Educated India.
Now, let us going to continue the Fibonacci search. We have another method is called as a Goldern section method. The Goldern section method, we start with the assumption of the numbers that we are going to conduct a large number of experiments. So, in a Fibonacci method, the total number of experiment to be constructed as to be specified before beginning of the calculation. So, let L2 star equal to f suffix n minus 2 by Fn plus into L naught. If the nu is equal to limit n tends to infinity Fn minus Fn by Fn minus 1 and L2 is equal to F2 by Fn minus 1 into Fn and so on it goes, so that L naught will come. So, proceeding in this way, we have everything will be cancelled. Finally, we have 1 by nu 2 will come into L naught. Now, the value is equivalent to L2 star equal to 0.38 to L naught. So, this is called as Goldern section method. Now, let us going to discuss one example. Minimize the function f of x equal to 0.65 minus 0.75 by 1 plus x square minus 0.65 x into tan inverse of x using Goldern section method with n equal to 6 and the interval 0, 3. Now, the solution is L2 star equal to 0.38 to L naught. Here L naught is maximum value is 3, therefore 0.382 into 3 which is equal to 1.1460. Now, x1 equal to 1.1460 and x2 equal to maximum limit 3 minus 1.1460, do that. So, that 1.8540 will come, that is x2. Now, we have to start with f1. f1 equal to 0.65 minus 0.75 by 1 plus x square. 1 plus x square is nothing but what here x1. So, 1.1460 and substitute it, you can get f1 will come, f1 equal to minus 0.2064 having the values of f1, and if you have a x2 corresponding f2 equal to 0.65 minus 0.75 by 1 plus 1.854 the whole square equal to minus 0.16902 minus 0.65 into x into tan inverse of 1 by x, 0.65 into 1.854 plus tan inverse of 1 by 1.854. So, we have minus 0.11512. Now, the interval is x2 to 3 based on the assumption of the bounds of the equations. Now, the interval of the equation consists of L2 is equal to 0, x2 which is equal to 0, x2 is nothing but 1.8540. so that the interval lies between this one. Now, the third experiment is placed at x3 equal to 0 plus x2 minus x1, which is equal to 0.708. Now, you take the graph, the maximum limit is 3, minimum is 0, and x1 equal to 1.1460 and x2 equal to 1.8540 is greater than x1 and less than 3, f1 equal to minus 0.20864, f2 equal to minus 0.11512, and compare with these two, right. F2, F1 is that is 0.20 and here is 0.11. So, F1 is less than F2 comes. Now, we have to go to the F3. F3 is compared with what the given value is 0.65 and substitute the value of x3, so that the net value is equal to minus 0.2886. So, F3 got it, x3 got it, x1 got it, x2 got it, and put it in the graph. So, maximum value of this one is 3 and x3 is 0.708, x1 equal to 1.146, x2 equal to 1.854, corresponding f3 equal to minus 0.2886 and f1 equal to minus 0.20864, f3 equal to minus 0.1151. Now, compare them. Here F3 is lesser than F1, F1 is lesser than F3, and then the corresponding x1 and x2 we take it. Therefore, the interval lies between, we delete the interval x1, x2. So, the new interval 0 to x1 you have to take it. So, x4 equal to lower limit 0 plus x1 minus x3 equal to 1.146 minus 0.708. So, the net value is 0.438. Now, we got F4, F4 substitute in the given equation 0.65 minus 0.6292 minus 0.3296 and net value is minus 0.3088. Now, we got x3, x1, x4. x4 having 0.438 compare with f4, compare with x3 is lesser than x3 and then corresponding f3 is minus 0.288, x1 equal to 1.146 and f1 equal to minus 0.208. Now, we have to delete x3 and x1 and take the limit 0 to x3. So, the lower is 0 and x3 minus x4 equal to 0.708 minus 0.438, we have 0.27 and substitute in the given equation f5 equal to 0.65 and another one is minus 0.6087 and then minus 0.37877, which is equal to 0.27842. Now, we have a graph plotting on the graph of a two-dimensional effect with deleting 0 to x5, because comparative with the f5 and f4, f5 is greater than f4 and f3 is in between f5 and f4. Therefore, omitting 0 to x5 and the new interval x5 and x3, I have to take it. Therefore, x6 equal to x5 plus x3 minus x4 equal to x5 is 0.27, x3 is 0.708 and x4 0.438. Substitute it, we have 0.54. Now, we have what x6, substitute in the given equation 1 and f6 equal to 0.65 minus 0.58067 and 0.37755 equal to minus 0.30822. Therefore, the final interval is x6 and x4, because x4 value is 0.438, corresponding f4 is minus 0.3088, x6 is 0.54, comparing with f6 is minus 0.30822, x3 equal to 0.706 and f3 is minus 0.2883. Now, f4 and f6 and 3 decimal places, they are equal, and compare with f3, f3 is greater than f6. So, omit the interval x6 and x3 between them. Now, it reaches, because f4 and f6 are nearest to one another. Therefore, L6 equal to subtract with 0.54 minus 0.27 because of x5, x6 minus x5. So, that 0.27 will come. Now, we have a Goldern search idea is L6 by L0 equal to 0.27 by 3, which is equal to 0.09. Next problem, find the minimum of the function f equal to lambda power 5 minus 5 lambda cube minus 20 lambda plus 5 by Goldern section method in the interval 0, 5. So, let us start with the L2 star. L2 star is nothing but 0.382 into L0. Here L0 its maximum value is 5, therefore multiply them with 5, so that 1.91 will come. Now, x1 equal to 1.91 and then x2, then f1 corresponding f1, calculate it. f1 equal to f of x1, f of x1 is substitute 1.91 in the lambda, lambda cube, lambda and so on. So, that minus 42.619 will come, and then we have a x2 equal to 3.09 So, F2 equal to 77.385 will come. Now, compare F1, F2, F1 is less than F2. Therefore, delete the interval x2 comma 5. So, the new interval x0, the new interval x0 is 0 comma x2. Now, we have the graph and F2 is here is 77.385, x2 equal to 3.09, F1 is equal to minus 42.619, that is corresponding x1 equal to 1.91. Now, the limit is 0 to x2, x2 is 3.09. Therefore, the rule is x3 equal to 0 plus x2 minus x1, x2 is 3.09 minus x1 is 1.91. So, the net value is 1.18 and substitute 1.18 in the given function, therefore, f of 1.18 equal to minus 24.527. Now, we have the value of x3, x1 and x2. x3 is 1.18, x1 is 1.91 and x2 equal to 3.09. We have f3 equal to minus 24.527, f1 equal to minus 42.619, now compare with the result of these two. F1 is lesser than F3 and then the corresponding interval we have to omit 0 to x3. Therefore, x4 equal to start from initial is x3 and then subtract x2 and x1. So, 1.18 plus x2 minus x1 equal to 2.36. Therefore, f4 equal to minus 34.713 will come. Now, we have a f4 minus 34.713. In the graph, x3 already we got it and x1 is 1.91, x4 is 2.36 because it is bigger than both x1 and x3. Therefore, f3 and f1, f4 is minus 24.52 for f3, f1 is minus 42.619 and f4 is minus 34.71. Comparative f3 and f1, comparative f1 to f4, f4 is greater than f1. Comparative f4 and f3 is greater than f4. Now, omit 0 to x3. Therefore, the initial value is x3 is 1.18 and subtract with x4 minus x1. So, x4 is 2.36 and x1 is 1.19. So, the net value is 1.63. Now, we have f5, substitute x5 in the given function. So, f of x5 is f5 equal to minus 37.747. So, in the two dimensional graph, x3 equal to 1.18, x5 is 1.63 and x1 equal to 1.91. So, comparative study with x3 is lesser than x5 and x5 is lesser than x1 and x1 is lesser than x4. So, omitting x4 to upper interval and then the limit you have to take it x5 to x4 x1. So, x5 plus x4 minus x1, x5 is 1.63, x4 is 2.36 and x1 is 1.91, we have 2.08. Now, we have F6. So, F6 is minus 42.661 is f of x6. Now, in the two dimensional effect, x5 is 1.63, x1 is 1.91 and x6 is 2.08 and x4 is 2.36. So, comparative study x5 is less than x1, x1 is less than x6, x6 is less than x4 and we have corresponding f5 is minus 37.747 and f1 is minus 42.619, f6 also minus 42.661. So, two decimal places comparative study they are equal. Therefore, what omitting 0 to x5 and then L6 equal to x4 minus x5 which is equal to 0.45. Therefore, L6 equal to 0.45 and L0 equal to 5. So, L6 by L0 equal to 0.45 by 5 which is equal to 0.09. Now, we have another example. Find the value of x in the interval 0, 1 which minimize the function f equal to x into x minus 1.5 to within plus or minus 0.05 by Goldern section method. The general formula of L2 star equal to 0.382 L0. Here L0 equal to 1 because the upper limit is 1. So, 0.382 into 1 equal to 0.382. So, x1 equal to 0.382, f of x1 equal to minus 0.42707 because x into x minus 1.5 substitute x equal to x1, we have f1, x2 equal to 1 minus 0.382 equal to 0.618, therefore, f2 equal to minus 0.54507. Now, you take a two dimensional graph. So, minimum limit 0 and maximum limit 1, x1 value 0.382 corresponding f of x1 is 0.42707 and x2 equal to 0.618 and corresponding f of x2 is 0.618 into 0.618 minus 1.5 is f2 equal to minus 0.54507. Now, compare them f1 and f2. f2 is lesser than f1. Therefore, the interval 0 to x1 omit it and then omit the initial state start from x1. So, x1 is 0.382 plus 1 minus x2 1 minus 0.618 equal to 0.764. Now you got x3. Based on the x3, f of x3 find out. F of x3 is substituted in the x into x minus 1.5. This is the equation 1. So, f of x3 equal to minus 0.5623. Now take the limit 0 to 1 and here start from x1 is 0.382 and x2 equal to 0.618 and x3 equal to 0.764. Now we have a f2. x2 you know, find f of x2. x3 you know, f of x3 you find out. Now comparative study with f2 and f3. f2 is minus 0.54, f3 is minus 0.56. Therefore, f3 is less than f2. Now corresponding the limit x1 to x2 omit. So, let us start with x2 to maximum limit of 0.764. Therefore, 0.618 plus 1 minus 0.764 which is equal to 0.854. Now, f of x4 equal to x into x minus 1.5 is minus 0.55164. Now, put it in the graph. x2 is limit interval, therefore, x2 equal to 0.618, x3 equal to 0.764 and x4 equal to 0.854 and maximum limit is 1, minimum is 0, omitting 0 to x2 because f2 equal to minus 0.54, f3 is minus 0.56. So, comparative with f2 and f3, f3 is lesser than f2 and compare with f2 and f4, f4 is lesser than f2. So, 0 to x2 omit and then x5 equal to 0.618 plus 0.854 minus 0.764 equal to 0.708. Now, we got f5. f5 is minus 0.56073. Now, x5 0.708, f5 equal to minus 0.56073, x3 equal to 0.764, f3 equal to 0.5622 and f4 equal to minus 0.55168. Comparative study with f3, f4 and f5 is f3 and f5 are nearly equal in 2 decimal places and f4 is greater than f3 and f5 and omitting x4 to maximum limit 1. So, the interval lies between x5 to x4 and then x5 initial value 0.708 plus x4 minus x3 equal to 0.798. Therefore, f of x6 equal to minus 0.56019. So, x5 we got it, f5 also we got it, x3 0.76 and f3 is 0.5622, x6 is 0.798 and substitute in the given function f6 equal to minus 0.56019. Now, compare them, all the values of 2 decimals are equal. Then we have x7 and 0.708 plus 0.798 minus 0.764, which is equal to 0.742. Therefore, f of x7 equal to minus 0.562. So, compare them x5, x7, x3, check it out, f5, f7, f3, they are more or less equal. Stop the iteration. Now, L7 equal to x7 minus x5, so that the value is 0.056. Now, L7 by L0 equal to 0.56 by 1 equal to 0.56. So, that is the convergence and it reaches, hence the problem.